Welcome to the mathematics class, students. Let us discuss the topic indefinite integrals session 4. And the aim of this session is to define the integration of product of two functions and to define the standard formulae. First of all, let us go to the theory part, that is integration by parts. This is the method of integration when the integrand contains the product of two functions. Integrand contains the product of two functions. Because integral of any product is not the product of their integrals. So integral of f of x and g of x, which are integrable functions, is defined as first function into integral of second minus integral of derivative of first function into integral of second whole dx. Here the selection of first function is very important. You have to select the first function as if its derivative vanishes after 2 or 3 steps or finite number of steps. First of all, here we go with the very first rule that if the product of two functions, one of the function is not directly integrable like log x, sine inverse, cos inverse, tan inverse, then we take the first function it as first function and the remaining function is taken as second. But sometimes here you will have like algebraic x and tan inverse x and tan inverse x. Here instead of taking x as first function, we will take tan inverse x as first and this as second. Observe this example. For example, integral of x into sine inverse of x dx. You need to find the integral of this one. Actually, here among these two functions, this one will have its derivative vanishes after finite number of steps. But this should be taken as first and this should be taken as second in such cases. Therefore, you will get this one as sine inverse of x into integral of x dx minus integral of derivative of sine inverse of x into integral of x dx and whole dx. This becomes here, this is x square by 2 into sine inverse of x minus integral of this is 1 by root over 1 minus x square into x square by 2 dx. Implies it is x square by 2 into sine inverse of x minus 1 by 2 is taken out and here x square, this minus is given here and plus 1 minus 1, distribute the denominator to this one in this way and now integrate. Therefore it takes, this becomes x square by 2 into sine inverse of x plus half into root over 1 minus x square dx of plus integral of 1 by root over 1 minus x square dx if you distribute the denominator. X square by 2 times of sine inverse of x plus half of, this is in the form of root of a square minus x square. Root of a square minus x square is equals to x by 2 into root of a square minus x square plus a square by 2 into sine inverse of x by a plus c. Using this rule, this becomes x by 2 into root of 1 minus x square plus a square by 2 into sine inverse of x by a is 1 plus this is nothing but sine inverse of x and half multiplies to this one plus side. So finally it is x square by 2 into sine inverse of x plus x by 4 of root 1 minus x square plus 1 by 4 of sine inverse of x plus 1 by 2 sine inverse of x plus c. Therefore integral of x sine inverse of x dx can become x square by 2 times of sine inverse of x plus x by 4 times of root 1 minus x square plus 3 by 4 times of sine inverse x plus c. It is of course a standard integral. This is how you will find out the integrals of such functions. But sometimes what happens, when there is no other function, then the unity is taken as second function in such cases like integral of tan inverse x. Here tan inverse x is taken as first and 1 as second. For example, we'll see some more standard integrals like integral of a sine inverse of x is there. Here, this is not integrable, so we'll take this as integral of sine inverse of x into 1 dx. That is, this is first and this is second. So, sine inverse of x into integral of 1 dx minus integral of derivative of sine inverse is root 1 minus x square into integral of 1 is x dx. Therefore, is x times of sine inverse of x minus, here to make it integrable, let us make it as plus and we'll make it as minus 2x by root of 1 minus x square, and we take half outside in this way. Therefore, to make it in standard form, it is plus 1 by 2 into, which is in the form of f of x power n into f dash of x integral dx becomes f of x power n plus 1 by n plus 1 plus c. So using this one, it will become 1 minus x square whole power 1 by 2 is 1 minus x square root over by 1 by 2 plus c. This gets away. So finally, integral of sine inverse of x dx is equals to x times of sine inverse of x plus root 1 minus x square plus c. This integral of sine inverse. Similarly, integral of cos inverse of x dx also derived in the same fashion, and we'll get it as x times of cos inverse x minus root over 1 minus x square plus c will be the integral of cos inverse of x. Similarly, let us find integral of tan inverse of x in the similar fashion by taking like integral of tan inverse of x into 1 dx, where this is first and second, implies this is tan inverse of x into x minus integral of derivative of tan inverse is 1 by 1 plus x square into integral of 1 is x. Hence it is x times of tan inverse of x minus integral of 2x by 1 plus x square and 1 by 2 is taken here. Thus it become x times of tan inverse of x minus half into, this is log of 1 plus x square plus c. Therefore, integral of tan inverse of x dx is equals to x times of tan inverse of x minus half into log of 1 plus x square plus c will be the integral of tan inverse x in the similar fashion. Next, let us find the integral of cot inverse of x dx as x into cot inverse of x plus log of root 1 plus x square plus c. Also, we can find the integral of secant inverse of x dx as x into secant inverse of x minus log of x plus root of x square minus 1 plus c. Also, we can find integral of cosecant inverse of x dx as x times of cosecant inverse of x plus log of x plus root x square minus 1 plus c. So here let us take either of the proof, like integral of cosecant inverse of x dx is also same cosecant inverse of x times of integral of 1 dx minus integral of derivative of cosecant is 1 by x into root of x square minus 1 minus integral of x1 dx. Therefore, it becomes x times of cosecant inverse of x minus this x gets cancelled, this minus into minus plus. So this is nothing but cos of h inverse of x plus c, and here cos of h inverse of x is taken as log of x plus root x square minus 1. So using this formula, we'll find out x cosecant inverse of x plus log of x plus root x square minus 1 plus c as integral of cosecant inverse of x dx. Similarly, we'll find out integral of sine h inverse of x dx. That is integral of sine h inverse of x into 1 dx. Thereby it becomes first function into integral of second is x minus integral of derivative of first function. Derivative of sine h inverse of x is 1 by root of 1 plus x square into x dx. Let us make up this function, that is x times of h inverse of x minus, take 1 by 2 outside, 2x by root of 1 plus x square dx. Again, this is in the standard form which I mentioned earlier, that is minus half into root of 1 plus x square by 1 by 2 plus c. This gets away. So finally, integral of sine h inverse of x dx is x times of sine h inverse of x minus root 1 plus x square plus c is under standard integral. Similarly, integral of cos h inverse of x dx we can find, that is equals to x times of cos h inverse of x minus of root over x square minus 1 plus c. Similarly, we can find integral of tan h inverse of x dx is x times of tan h inverse of x plus log of root 1 minus x square plus c. It is another standard integral. Like this, we can find out the standard integral with various methods. Like now, the question is, what is the measure of finding the first function? If both functions are directly integrable and the first function is chosen in such a way that the derivative of function thus obtained under integral sign is easily integrable. So what is the preference of order in the first function is, the preference of order in the first function is this one, that is I late. I stands for inverse functions and L stands for logarithmic, A stands for algebraic functions, and T stands for trigonometric functions, and E stands for exponential functions. Say, for example, if you take integral of x e power x dx, here even though this is algebraic and this is exponential, and this should be taken as first function and this should be taken as second. And if you take integral of x square into sine inverse of x dx, even though it is algebraic, whose derivative vanishes after 2-3 steps, we'll take this is inverse trigonometric function, so we'll take this as first one, this as second. Similarly, integral of x of log of x, as it is algebraic, it is logarithmic, it should be taken as first function, it should be taken as second, even though its derivative vanishes after few finite steps. So this is the base for preference of selection of first function, but there are exceptional cases. So we shall see the various examples where we can find it out the functions.